How's it going, everybody? In this video I'm going to go over some of the changes that I have decided to go forward with our CCIE labs and our preparations for CCIE when it comes to all the layer 3 technologies. We're still on track for the CCIE labs. I just had to take a little bit of time to reconfigure some things when it comes to the actual implementation of stuff and how we're going to handle things going forward. So what you have in front of you is the Vsphere client for Esxi. So this is going to be the client you use to manage your Esxi host. So if you're not familiar with VMware, I've actually got an IBM server that I load Esxi to. I have 2 Intel Xeon processors and about 64 gigs of RAM available to the server, and I have 2 70 gig SAS hard drives, which gives me about 130 some gig of storage space. So I don't need a lot of storage space to do what I need to do for this, so we're going to run with this. So what I've done is I've loaded approximately 20 CSR 1000 Vs to this Esxi host, and I've actually got a video dedicated to this. And it's, if you look at the CCIE V5 lab setup, you'll see I walk you through how to set this up with how to import and set everything up. So what I've done is I went ahead and I did this. And a couple of things that I want to show you just to give you guys an idea of where we're at with how this is all set up. Currently I have 14 of the 20 CSRs actually operational and running. So if you decide to go out and you want to run this in VMware Workstation, it will be supported in that. The difference between the two is you'll have to make sure that when you go in and set it up to where you'll have to set the IP address correctly inside of your what do you call it? If you run Esxi inside of Workstation, then you may have to make sure that you disable the firewall for Telnet over the network, and then effectively place your serial port and things like that on the router, and then you'll be able to Telnet into the router through the IP address, and you'll be able to set a Telnet port. So not 23. It'll allow you to use something other than that. Typically I use 2301. 2302, 2303, 2304, so on and so forth through 2320 as I go and set these up. So it gives you some flexibility when you're going through. And in addition to that, when you're in the configuration section, there's a couple things you need to do. You need to click on over here. I go to on the host, click on configuration, and then on the standard switch. What the standard switch doesn't allow you to do a whole lot. Basically, it allows you to set up different VLANs. It allows you to have multiple port groups. VM kernel ports, depending on what you want to do. If you want to do vMotion or stuff like that, very, very basic configuration with the standard switch. It doesn't allow you to do a whole lot. Now, if you get into distributed switches inside of the Enterprise Plus configuration, that is only available inside of vCenter server. You'll be able to do that, and a lot of companies I know run that because it gives you a lot of flexibility, like doing ether channels and stuff like that. But from a standard switch perspective, you need to do a couple things. You need to make sure you are using VLAN ID all, which is 4095, and then you need to allow promiscuous mode to go through. So the way you would do that is you click on Properties, and then you would click on, from this one, you click on Edit, and then right here where it says Security, normally it would tell you promiscuous mode, you have to set it to accept it, and click on OK. And then from here, click on this guy. So I did the vSwitch, 120 ports. And then you were to so that's what I just did that one. So now promiscuous port is available. If you click on the VM network where it says all 4095, you click on Edit, and then you go to here. That'll be where that's at. And if you click on Security, click on Accept. So do that in both places, and click on Close. The next thing you need to do is on the host, click on Security Profile, click on Properties over here on the right, and then drag it down a little bit until you get to where it says VM serial port connected over network, and then the port range that it'll accept for. Make sure you click on that. That's going to allow the Telnet session to go through. And then click OK, and then go ahead and deploy. So for instance, in this case, I'll click on R5, Edit Settings. Normally what I do is I go to 2 gigs, I click on CPU, I always give it two sockets and 2 cores, and then I click on Add. I click on serial port, click Next, connect via network, Next, and then I type in VM listens for connection. and I copy and paste this in. Oh, well, obviously that's not going to work. So you type in telnet : / the IP address of the host, and then the colon, in this case, is going to be the port number. And in this case, this is CSR15, so it's going to be 2315. Click on Next, Finish, and OK. Now it shows up here that you have this set up. Click OK, and now I've associated it to that. Now when you first fire up the CSR, first thing you're going to want to do is you're going to click on it, and you're going to click Power On, and you click on Console. And then this is going to fire up. Click inside of it so that the hand goes away. Then mouse or arrow down to this guy and hit Enter. So you're going to log in via the serial connection and not the virtual console. And then from here, since you have this guy set up, then you can bring up Super Putty or whatever terminal emulator you want to use. And I've got 14 set up, and I'll show you the topology here in just a second. Click on View, and then Sessions, and I have mine set up as Esxi, so I know which one to do. Click on here, and then you're going to right-click on this. If you don't already have one, you can create one, or you can right-click and click Copy As. I usually do this and tab out to bring 15 down, tab over again, and then just replace the port number. Click on Save, and then right-click and click on Connect. So now what's going to end up happening is you'll see it pop up. What's going to end up happening here is you're on the virtual console here, but you're going to see the serial output here. So what's going to end up happening is it's going to take a few minutes for it to spin up. Once it does its spin up, then you're going to be able to go in there and let it install. Basically, it's what you're letting it do. So it's actually it's a multi-step process. So you're going to go through, it's going to install. It's actually going to reboot after it gets to a certain point. And then once it reboots, it'll actually log in, and it'll show you a pop-up of what you want to log into. And you're going to see a golden images and a packages.conf, so it's a configuration package, which is how the iOS XE platform actually operates. And then from there, what's going to end up happening is it's going to go through the entire boot process, and after it stops, you're going to want to wait a minute for it to do this. Then you're going to get one where the very last line of config is the last word is going to say details. And so if you see details pop up, then you're going to know that you're at a good place. Hit Enter, and then just type in router with the right arrow, the greater than sign, or I'm sorry, the greater than sign, and then you're going to hit Enter, and then you're going to want to go to global config and do two things. You're going to want to type in global config license boot level premium, and you're going to want to jump out of global config and write that to memory. So do a write mem, and then reload the box. What that's going to do is it's going to unlock all the advanced features. So basically you're going to go from like IP services to advanced enterprise services in one configuration. That's good for 60 days. Now what I mean by 60 days is what they give you is a evaluation license. So typically what ends up happening with that is you enter the license premium, and what that does is it gives you full throughput for that period of time. So basically it lets you try it out as you're going through your setups, and is this going to work for me? And then after a certain point in time, they say, okay, you've had it for this long, we're going to reduce your bandwidth down to say 5 megs or something like that. Well, I don't care about the bandwidth. I care about the features that are available and what I can configure as I'm studying for my CCIE. So at that point, I don't really care at that point. And what ends up happening then is you go in and you are able to pretty much just grab what you need to from there and play with it. So add in whatever you need to and go from there. Now, typically what ends up happening with Vsphere is they give you a 60-day license for free. So basically what they do is they give you Enterprise Plus licensing capabilities for 60 days. And this gives you every feature that's capable of doing that. So you can run, if you're so inclined, you could go in here, and it's actually going through the reboot process right now. And as you can see, this only takes a few minutes. Now if you see this packages.conf, it's going to boot to that, which is going to be the actual boot file. So it did its initial installation, and now it's going to go back through and actually load up to the operating system. So basically kind of the same thing with Windows. As it goes through the install process, it reboots, and then it goes in and installs, or it boots to the actual operating system, so something you can actually work with. Now the main thing the main sticking point here is when it gets booted up and everything's situated, understanding what you can do with it is going to be the main thing. Now this is iOS 15.4, so obviously it's going to be more features than what we're going to need to with 15.3. But one of the main things that I was having a problem with 15.2 was there's a lot of configuration as I was going through full-scale labs that I was running into a hiccup with. Okay, I couldn't do that in GNS3, I couldn't do that in GNS3, so I would write down as I was going through the solving tasks in the full-scale labs. I was like, okay, I think I would do this, but that capability wasn't there. So I was like, okay, and I ran into that so much that I actually couldn't complete the lab. I think 40% of it I couldn't do in that iOS level image. So I said, you know what? Why don't we just cut the BS and let's just jump right into CSR? Because I'm going to be, to me now I'm in like game on mode now, to where I really want to dig into this stuff and really get a hard charge and get it done. And I'm full scale labs now. I'm done with my. Well, actually, I still have to do the security side. I still have to get that done. But what I'm going to do is, in addition to the security videos that I had to do for the technology videos, I'm also going to start kicking out specifics to like Ospf v3, deeper dive in MPLS, stuff like that. So at this screen right here, this is a brand new router. Okay, so you're going to type in enter or a no and then hit enter. So we don't want to do the initial configuration dialog. Which, if you're brand new to CCNA or you haven't touched it in a while, basically it's a command line wizard that allows you to set up the management IP address, the interface addresses, the masks to them. I believe it does even DHCP if you're so inclined. But this way here, it'll allow you to give it everything dynamically, effectively. So it's just a wizard that walks you through there, and I don't really care for that. Now, remember how I mentioned you'll see details is the last one? Well, that's actually what you're looking for right here. You're going to hit enter, and now you're at router greater than sign, so user mode. So we're going to type in show privilege, show there is a, in some cases you can do show parser view. No, that's not what I was looking for. But anyway, basically what it is it'll basically at user mode you're at privilege level 1, and trying to figure out what that command was, but enable, and then you're going to go to global config, and I do three things. I type in license boot level premium. I accept the EULA. Alright, so then it goes through there, and you just hit enter a couple times. So I go into the line console 0, because that's actually what you're on, is line console 0. I type in no exec timeout, and then I type in logging synchronous. I type in host name. Host is going to be R15, and then I exit out. I jump out of here. I type in write, and then I type in. I do one additional thing now, since I've been setting this up a few times. I type in copy flash or copy running to the flash. And I'm going to name this pre.ip.addressing.cfg. And basically what that does is, actually no, I should do this ahead before I do that. Let me reload. It only takes a second to reload, or a few seconds. But basically what I end up doing here is I get it set up to where it's going to do premium boot level, and then I go in and I'm able to when it reboots here, like I said, it only takes maybe 3 to 4 minutes tops. So once it gets reboots, I'm able to go in, and as you can see in the background, you can see it doing some stuff. And you get down to a certain level here, it'll actually pop up and it'll say VMware, and you can see it does the same thing here twice. I'll get to a certain point, this guy will pop up packages.conf, and then you're in a good place, and then give that a couple seconds, and then it starts booting up. It does a SHA-1 hash calculation to make sure everything is copacetic. It does that, and this guy goes to an init load to something else. It stops at the grub loader, and then goes from there. And then on this side, your virtual console. I would recommend you not worry about any of the pop-ups you get. This is because this is basically ASR 1000 code. So basically, they took an ASR 1000 box and they virtualized it. and that's what CSR 1000V is. So it's the same code as an ASR 1000 box. So you get to this point right here where you're at run level 3, this, that, and the other. So you're good here, and you bring this guy up here, and then eventually you'll get to the full boot, and then we'll be at full readiness and operational. And then you can go in, and what I do is I type in a pre-IP-addressing.cfg, and I say that to the flash, because what that basically allows you to do is, if you want to do a whole bunch of labs, you can literally, okay, and it's just about loaded here, and I'll show you what this looks like in the directory here in a minute. But basically what that gives you the ability to do is, let's say for instance you want to do a whole bunch of different labs. Well, if you have a whole bunch of different labs, you can actually save the IP addressing on a per configuration file basis. So then you can do a configuration rollback and roll back to a different configuration version. So you can say configuration file, you want to change the information over to something else. So here we are, we're at this guy, we're going to type in enable, we're going to type in copy, actually we type in dir, and this is going to give you the files for everything. So right now, as you can see, there's the packages file, you have some other stuff in here like the iOS image. So this guy right here is the package file. This is the iOS image right here. So in case you want to test out some things like weighted random early detection and do that, this is the file you would do that on. So what we're going to do is we're going to type in copy run to flash, and we're going to type in pre.ip-addressing.cfg and hit enter. And then yes, we want to do that, and we're going to type in dir. And now we have this guy sitting here right here. So basically what this does is, if I go in here and I make any change to this router, and let's say for instance I want to, and if I type in show IP interface brief, what I have is 3 gigabit Ethernet interfaces sitting here, administratively shut down, no IP address, nothing set. So now what I can do is, if I want to go between, say for instance, a hardcore MPLS lab, I could do, say MPLS, say multi-VRF or MPLS multi-customer. If I want to test different features out, or multi-whatever. I could, if I want to go between configuration files, I can do that. And then I can just type in rollback pre-IP addressing.cfg, and it's going to roll back to this point. And I can punch in my IP addresses or a feeder file from a vendor if they have a lab that I want to try out, and then go from there. That's basically what I end up doing. So I wanted to shoot this video just so you guys had an idea as to how I do stuff. I'm going to put this in with the CCIE labs just so you guys have an idea as to how things are going. I'm not, like I said, I didn't have to go through and do a full installation of Vsphere for you. I didn't have to go in here and do a installation of CSR 1000V. It was already done. So the nice thing about this guy is, if you were to click on this guy, if you were to download CSR from Cisco's website, and the last time I checked it was free. So if you were to go download it, and you were to go to File and type in, click on Deploy OBF Template, and point your the uploader and the installer to the file. So I've actually already got it saved here. Click on Next. It says it recognizes that it's a CSR 1000V, which is a cloud services router. And then what you're going to get if you thin provision, this is how big the file is supposed to be. And if you thick provision, it's going to be this big. So it gives you a lot of flexibility. So technically speaking, between all of these routers, I wouldn't have enough room if I was to go thick provision. I only have 130 gig of hard drive space. So you figure 8 times this, 8 times 10 is 80. So it would be close. I'd be able to get 15 routers on there. But by thin provisioning, you only use as much space as you need. So you've got 10 gigs, but you're only going to use what you need of that 10 gigs. But technically that 10 gigs isn't hard set. So it's not like a resource allocation to where, or reservation where you have 10 gigs and nobody else can use that 10 gigs. That 130 gigs is available for all the routers on that host, and you can spread it among all of them equally, as long as you don't take more than what's available for all of the devices. So it's kind of like with FairQ and quality of service, to where if you want to take, and instead of having just one just a configured gig of bandwidth on an interface, and saying, okay, that you're going to allow whatever flows to go through that interface to use whatever amount of data or bandwidth they need. With FairQ, you're going to evenly distribute it to all of your devices, or all the flows, and not choke out one little guy where he might need only a couple hundred K. So where with weighted FairQing, you can specify how much a particular flow is going to get based on a particular weighting value, whether it's a DSCP value or bandwidth reservation, things like that. So you can do a lot with that. So basically the same thing applies here with your provisioning side. So I always go thin provision, and I'm going to click cancel on this because I don't need to go that far. But it gives you that ability. You can go through and get it all that stuff set up. So the last thing I want to show you real quick, I'm going to minimize this. This is our topology. So I have 14 routers set up right now, and they are completely separated on here. So basically what you have, let me click on the pencil. What we have here is I have this would be effectively the VPN core, so MPLS VPN core. And the reason why I'm focusing on two different things. I'm focusing on BGP, MPLS, DMVPN, and quality service and security. The reason I'm focusing on that, and multicast. The reason I'm focusing on that is because the IGPs, RIP, Ospf, VIGRP, and those guys, I've got those down pat. I don't need to rehash. I don't need to go back through and really test those. I will be testing the IPv6 versions of those, so we'll be doing a lot with EIGRP named mode, Ospf v3, RIP-NG. We'll be testing those guys out and trying them out. We'll be doing a lot of redistribution, dealing a lot with MPLS, because we're going to be doing it to where we have a multi-provider core, or not a multi-provider core, but a what's the word I'm looking for? A multi-customer core, or multi-customer implementation. So we'll have, this might be customer 1, this might be customer 2, this is supposed to be customer 3, and 2 and 3 should be able to talk to 1, but 2 and 3 can't talk to each other. So we might have a situation like that, and I want to go through stuff like that to where you guys can, I'll set it up, and we'll have redistribution going between them and seeing how that would all work, and go from there. Because as I'm digging into this more and more, I'm realizing that there's some limitations with the technology labs that I didn't go into the detail that I needed to. So I'm going to be focusing on those. I'll type in. It'll be specific. It'll be at the bottom. So I plan on getting security out sometime soon. I plan on getting and I'll have a bunch of videos on top of that. So the CCIE labs themselves will be specific to technology-focused stuff. So we'll go through and we'll set up. Hey, this is going to be how stuff is set up. This is how you need to go in and get everything operational. And then down here in DMVPN, I have a pretty wide swath of information I need to cover with that, with the multiple tunnels, and I'll do DMVPN across this guy here as well. The reason why I've got such a highly redundant core is to give us the ability to test different features with IGP. So if we want to go through here and do some weird Ospf deployment, we could do that. Now I'm not going to limit myself just to this topology, but it gives me the flexibility to do so. So that they're two independent topologies, but they're on the same devices. So the way that I've got to configure it is these are all .1q interfaces set up with the IP addressing. IP addressing is already done. The loopbacks are set up as such. So as we go through here, we'll be able to test things and work on different stuff. Because, like I said, as I'm going through the full-scale labs, I took one last night or yesterday, and I took the lab. I would consider it to be a difficult CCNP lab. I would consider it to be an expert level lab. And the reason why I say that is because a lot of the stuff, I knew what they were asking me as I was reading the question. On everything. I was able to go through everything, and I noticed that's where I noticed a lot of limitations with inside of GNS3. And I couldn't do this, I couldn't do that. I was looking at it, I'm like, yeah, I think that's how I would do it here, but I couldn't do it because of the fact of XYZ issue or limitation in the operating system. So I say, you know what? Screw it. Let's just jump in with CSR 1000V, and we can have no limitations. We can just dive in and get everything operational and go from there. So the reason for this is because of the fact of some of the limitations I've ran into and not wanting to have those limitations. I want to be able to go in there and configure it. I'd rather have more features available to me than not enough, and go from there. So this is what you guys are going to be seeing as we go through here and stuff like that. So if you guys still want to follow along with GNS3, you're more than welcome to do so. I would recommend downloading at least a few CSRs if you have the capability. They do take a minimum of 2 gigs of RAM, and you can run them inside a VMware workstation if you'd like. I would recommend against that directly. I would recommend installing, if you have a computer that's got the capability of running it, I would recommend VMware, or I would recommend Esxi inside of VMware workstations. So you can do nested virtualization, and then you can load the CSRs inside of you can load the CSRs inside of VMware running on top of workstation, running on top of your computer. And you're going to need a box that's pretty beefy. And as you can tell here on this guy here, bring it back up. If you look at the summary here, I've got 64 gigs of RAM, and I'm using about half my CPU. And at the computer, they're just sitting idle. They're not doing anything yet. So that is quite a bit of CPU usage. But I gave 2 sockets and 2 cores to each device. So if I was only to use one, I think it'd be a little bit lower than this. But it is what it is. So that's what you guys have to look forward to as we go through here, and go from there. So I hope this has been informative for you. I know I have to thank you for. Oh, there. One last thing before I let you guys go. The full-scale lab will be coming out. I wanted to go through the technologies like I've been, and I plan on going through a lot of that type of stuff. So actually, the main reason why I did this is because the expanded blueprint, I was finding limitations in not knowing every detail that I thought I knew, and that's the whole reason for going back through and say, okay, do I know this? Do I know that? And rating myself. I can actually bring it up. I actually have it pulled up right. I think it'll load over here. Yeah, it does. I actually went through the expanded blueprint and I copied it into Notepad, and then I was honest with myself. Okay, how strong am I with all these technologies? And so I gave myself 5s for something. I'm very familiar with port fast, uplink fast, backbone fast, BPDU guard, BPDU filter. Off the top of my head, I don't remember which one does what, but I know I know for the most part how these things operate. And most of the time, I gave myself 3s and 4s. I was modest with myself on some things, but I went through and I was honest with myself when I went through these. Okay, do I know how to do this? Okay, yeah, I'm pretty sure I know how to do that, and go from there. But the idea behind it was, as I was going through the full-scale labs and looking at the solutions guides, I realized, okay, I didn't even think about that. And it's just designed to, okay, how would a true CCIE that's got the IE, got a number, how would he do this? And then by taking that perspective into play, I was like, okay, because yes, I would consider myself to be knowledgeable in all technologies, but I might not always think of all possible solutions. So it's good to test yourself. The other thing that I also am doing is I'm taking the full-scale labs from the version 4 CCIE and flipping them over to version 5 CCIE. So basically what I'm doing is, let me give you an example of what I mean by that. So basically what I'm doing here is you are looking at INE's version 4 full-scale labs. Now I paid for these guys outright when I got them. It's been close to 2 years now since I've had these labs. I've gone through a couple of them, but basically what I've done is, where you see all this frame relay stuff here, I've basically taken what would be the frame relay switch, which is to actually backbone 2, I believe is the frame switch. What I've actually done is I'm incorporating another router. So if I took the backbones out, and actually no, we could do that. But basically what I've done is I've got 13 routers, which is kind of the reason why I stopped with 14 routers with CSR for the time being when I'm doing the labs, is I'm taking these guys and the frame relay switches that you see here. I actually use another router and I do the sub interfaces, and I run DMVPN over those. So whatever this subnet range would be, like 123. So this is 183.1.123.0/24. That's what I run with. And then this is DMVPN. So this would be 2 different DMVPN clouds that I would run. Or you can run over the same, but 2 different tunnels, and do that. Or 2 different. You can run 2 different tunnels, 2 different keys. Or I commonly refer to this to be a dual tunnel single cloud. So, or dual hub single cloud, to where you can have 2 clouds running, and they have reachability on the back end. So, for instance, 1 and 5 have reachability on the back end between your switch 1 and switch 4, which I can flip out switch 1 to be say or router 7. You know, because I got 6 main routers and I have 4 switches and 3 backbones, so I can go in here and do routers 1 through 6 are the core, and then the main routers that are doing a frame relay, and then go from there. So it gives you a lot of flexibility. So I'm taking those, and then in the full scale labs, if I was to pull these guys up, if I was to click on lab 1, let me bring this over, to get the 20 labs here. Now this is going to correspond to this topology, right? So if I click on here, this is going to be a 6 out of 10 being the highest. So I said, okay, well, let's look at the first lab I ever did was a 6. So I was like, okay, now I know what it's a difficult CCNP lab, if you will. So again, it starts off where it has you come in here and it says, okay, I want you to do these features. Now I'm not going to give all this out. If you're good at Googling, you can probably find this online for free, or you can be like I did and actually pay for it. So I paid, I forget what it was, a couple $100 some time ago to get this, and I got the version 5 lab workbook for free with my upgrade when they released it, because I had an all access pass. I still do have the all access pass. So that's what basically I did. So basically this runs you through and how to get everything operational. So this gives you a lot of flexibility when you're going through your setup. So and the reason why I'm showing you this is because I've noticed a lot of guys that are studying for CCIE that are reliant on the reliant on vendors to create labs, which is fine. You can totally do that. I'm more of a proactive type of person, where I'm like, okay, you've given me 2 labs and some foundation labs and some troubleshooting labs, because I use INE by default. So I'm like, okay, cool. You've already given me a starting point. So now I can say, I could basically take what you've written here, so over the frame relay, and I can correlate to DMVPN. So I can go out there and come up with some really off-the-wall stuff. Okay, what are the limitations that I could do? And by digging into the technology, you can pretty much learn whatever you need to about it. So you know that there's only, say, 15 things you can do with DMVPN. This is more theoretical. That there's 15 things you can do with DMVPN. Well, that's great, but the thing with DMVPN is, if you know what the 15 things are you can do with it, then you can start working with building yourself up to, say, doing 6 or 7 or 8 or 9 of those things in your lab preparation. So where this would be frame relay, you could say, okay, make sure that R2 is the hub, and that R1 has to use R2 to get to R3. Well, there's a direct correlation between frame relay and DMVPN in a lot of respects. So you can totally do that, where you have to go from spoke to hub to spoke. Or you could say, I want to be able to spin up an IPsec VPN between R1 and R3 and not have to go through R2 to get there. Okay, well, then you're going to be using phase 2 DMVPN. Now, it might even tell you, don't use the shortcut command to do that. So you know it's not going to be it's not going to be phase 3. So there's a lot of features that are going to map directly over to how you would set this stuff up. So I don't know how. If you're not familiar with frame relay, don't worry about it. You don't need to be. So just what I've done and what I'm going to be doing is basically just removing frame relay and replacing it with DMVPN, which is, I believe, is what the Cisco 360 program has done. They just removed frame relay and put DMVPN in its place. Like I said, there's a lot of similarities in its restrictions with different protocols, like with Ospf and the timers being different because you're going over NBMA, and then the Ospf DRB DR election when you're doing broadcast. And if you're going to do a point-to-multipoint, you can do that as well. So a lot of flexibility with how that stuff works. So I would recommend, don't be afraid to tweak some things to keep labbing. So I'm going to be doing all 20 of the full-scale labs. I'll also be doing all 20 of the troubleshooting labs and then the speed labs. And the reason for that is because it's already been done. All I have to do is make some changes. So all I have to do literally is just go in here and say anything that's serial or fast Ethernet, I just have to switch over to gig 1 dot whatever. Now, one of the things I'm doing to do that is what they call text crawler. Text crawler is a free, open source program, which you can use. So basically all I've done now is I've gone in here and I used the free version, and I click on close to get it open, and then I point it to the source file. So all I do is I click on, I select the folder and I type in whatever it is, and then I type in here, well, this would be like the find if you were in Notepad++. I just say, okay, I want to find this particular thing, so I would go in here and I would say, I want to find anything serial 0/0/0. And I will want to replace that with gig1.1. And then I want to, actually the cool thing about this is it actually gives you some flexibility here. You can actually go in here and do, it says insert after, and then you can type in space here, and you can type encapsulation.1q and have that sitting there. Now, it doesn't do everything for you. I mean, you can go in here and say encapsulation frame relay, replace with nothing, so get rid of frame relay. You can type in the map statements. So you can get really granular, or you can do what I do, and like literally when you're dropping your configs on these routers, just go in here and take a minute per config and just whack whatever frame relay is in there, and it's not going to be perfect all the time, but just save it as another file. Later on, when you get to that, when you want to dig into it, go ahead. For connections between here, backbone 1 and R6, which is going to be how it's going to be all the time, all I've done is I just set up I set this as PPPoE, so I have a client and I have a server, or a server and I have a client. That'll give you some flexibility there. GNS3, I will still do the PPP configuration, so actually I have a 10 router set up there with a couple of peers, so I can do multi-link PPP if I'm so inclined to do that. I can go from there. And for the backbone, or for the switches, these are just another router, and then I make sure to do a peering between them. Or if it's going to be a shared LAN segment, I make sure that's an extra router on that LAN segment. So the topologies aren't as big, but the technologies are still there. So it's a matter of going through and saying, okay, how would I do this? How would I get the redistribution to work? And the idea is to challenge yourself. Can I make this work? And obviously my end goal here is still to have a topology that looks like this. I'm still planning on doing that. I'm absolutely planning on getting this stuff done. But just be cognizant that things don't always work out the way you plan them. And the more I've dug into it, the more I'm like, oh, okay, where am I? Okay, there I'm at. You can't always do it the way you wanted to do it. So I still plan on going through this. And actually, I had an email come in with, how do you plan on doing the DMVPN? Well, I could do DMVPN over the MPLS network. I could totally do that. Or the better way to do that would be over non-MPLS, to where if you had a backup connection, so where you had this could be your tunnel 1, and then you have tunnel 2, and then tunnel 3, or they're all tunnel 1, and then they go down to all these locations. So you have a bunch of VPN tunnels, and then you would have, say, a different color. So you did a multiple tunnel, and then you had this setup. This is another tunnel. So you had 2 tunnels going to every site, so you have redundancy, and going on and on and on down the way. Now, like I responded to this gentleman's email, I said, you never know what you're going to get. Or you could do it, you could say that that's going to be set up on that router, and then you're going to have this guy going to this guy. So you're going to have redundancy regardless of which direction you go. And that's kind of the purpose of CCIE. Your goal is to be, okay, how can I solve this? And depending on the question, will dictate how you're going to answer it in most cases. If it tells you to implement Ospf but don't use the network statement, that's going to tell you right then and there you got 2 shots. You can either do the interface level commands, or I can say do not use the network statement or the interface level statement. So that means you're going to have to redistribute. Straightforward. But if you don't know how that works, it's going to become difficult for you to do that. So, excuse me, that's my goal here, and I'm trying to mix it up as much as I can with my setups. Go through and make sure everything operates and stuff like that. One of the things that I wanted to point out to you real quick was, let me minimize that. Oh, where'd it go? Oh, there it is. Like this guy would be BGP. And the reason why I would do this is because of the fact that I don't want to have it directly connected. So where it would actually be simulating internet here, and you actually going over the internet. Because that's usually how it's going to be anyway. That's how I've set it up in the past, is you actually have internet connections between there, and that's how you would go through and actually do it. So you can do it however you like. That's just my methodology. So now that we've changed that, and let me take a quick peek. Let me bring this over here real quick. Now that I've done that, let me quick. I know you guys can't see this, so that's why I'm being kind of quick about it. So the last thing we touched was on December 14th, so a week ago. I did. What did I do? I did stub areas, stub and totally stub, not so stubby areas, and then translation, virtual link troubleshooting. That's not very intuitive. I just noticed that. So basically, I'm gonna pick up kind of where I left off, and I'll show you. I'll map out on the topology. I'll be like, this is going to be area 0. This will be area 1. This will be a stub area. This will be a stub area. You know, these guys will be stubs, and then we'll, have this redistributed in. This will make this a not so stubby area then, or I won't redistribute that in. I'll have it advertised in, and then I want to choose, particular direction. I might add a link in here and add a link in there, so we have multiple places to go, just so you guys have some flexibility with when you're doing your setups, because having multiple exit points is going to be the ultimate test. Okay, can I get this to work? And I've found some ways to do that to make it actually work that way, and it's actually very, very simple. But like I said, it's one of those things where you got to start testing features out, and that's why we're going through the full scale, the CCIE labs, just so we know how everything is set up. And like I said, there's no slide work with it. It's all configuration. So when we go through MPLS and we're doing multiple import-export setups, particularly when we get into like having all BGP or an IGP as our PE to CE routing protocol, more advanced configurations, stuff like that. There's been quite a few things. Like if I was to go back over to this guy here and scroll down to MPLS, which is down at the bottom here, MPLS. It doesn't say this in here, but it says LDP. But the problem with that being is it doesn't say anything about LDP authentication. So I got hung up on that in one of my labs. It's like, I don't know how to do that. So that's one of the reasons why we go through that. We're going to test different things out, make sure we know how that type of stuff works. I would definitely recommend knowing how that would work. Same thing with BGP. We're going to spend the majority of our time on the topics that I'm not as familiar with or strong in. So, like I said, BGP, MPLS, multicast, quality of service, and some of the security features that are more advanced. And we're going to be testing those over and over and over again. We're obviously going to have IGP there, so make sure we hit IGP. But we're going to be dealing with the multi-address family feature. So we're definitely going to be dealing with Ospf v3 and how that a lot of the Ospf v3 and IPv6 Ospf commands are the same, because realistically speaking, you're dealing with multi-address family when you're dealing with Ospf v3. And some things have to be configured underneath the interface, some things don't. And I found some stuff out by testing it that, and a lot of the times it's reading through the configuration guides. I mean, that's basically how I found. Let me click on this, and I'll bring this folder over real quick for you. What I've done is I have the configuration guides. I downloaded them all. This is just some miscellaneous stuff that I've looked at. I click on configuration guides. I have some other stuff in here. Click on routing in here, and then I have the Ospf configuration guide. So I'll bring this over. So I downloaded this from Cisco's website. I said, okay, let's take a look at Ospf v2 cryptographic authentication, or I'm sorry, Ospf v3. So cryptographic authentication with IPsec. So I come down here, and it's not a huge section, but it's still, configuring it isn't very complicated. But notice how it's doing one of the following, either Ospf v3 or IPv6 Ospf authentication, and then go through and test it out. I did not know that you had to have different SPIs if you're going to do authentication and encryption on the same router, going to two different guys. So what that means is if I'm going to configure on router 12, if I'm going to do OSPF authentication here with IPsec, and I'm also going to do encryption over here, but I can't use the same SPI because the SPI is per tunnel. So things like that pop into play. I was like, oh, and it gives you a warning message. I mean, it's like, duh. I'm like, oh, but I didn't know that. Didn't know it until I typed in the command. That's why you test these features out, so you know what to expect. So a lot of this stuff is going to be my own motivation going through and making sure that I know how this stuff works. So taking a couple of labs has proven to be insightful. And actually, I was going through the level 7 topology, and I was like, I don't know what he means by that. So I was going through, and basically what I was doing is I was doing a mental lab in my head. Okay, how would I configure that? So based on the restrictions, I couldn't do this and this and this. So then I was like, okay. So basically what I did, I took the lab and I drew it out on a piece of paper with a pencil, and I said, okay. And I went on a per section basis. So I got to a certain point where I was like, okay, if I quickly did not know off the top of my head how I would configure it, I would write a question mark and then the section number, say like 1.2, and then whatever the bullet number was. So if it was bullet number 2, I wrote down 1.2.2, so that when I got to the solutions guide, I could say, okay, how did he solve that, and how could I correlate a solution with a task, so that when I got farther along, or when I'm in the actual lab, I can go, okay, I've seen this before, and then I'm not hung up. So I go back and it's, reinforcement. Now, I was almost tempted to go out and get IP experts full-scale labs, because I think they have 4 or 5 of them, and just to try them out. And now that I've gone through a couple labs, I'm like, okay, this is making sense. So, like I said, the nice thing about it was I actually went up to my wife the other night and I said, you know what? I said, I just took a lab. I took an 8-hour lab in 3 hours. And she said, how'd you do that? I said, simple. I went in there and it was a mental lab. I didn't have to actually configure anything, but I would just say, I wrote down that, this task number, I would do, I would answer this question. So I would type on router 1 through whatever, I would write in this underneath the interface. And I went and I verified it against the lab tasks, or the solutions guide. I said, oh, I would have got that right. And, based on that. And then I said, okay, what other solutions? And I wrote down all possible solutions. So when I was in a layer 2 scenario, it said, make sure you limit the amount of VLANs going across. I said, okay. I could potentially do the VTP pruning, to where I could set the prune eligible list, and I could do this, or I could do a VLAN allowed going across the trunk, to where I could only allow certain VLANs to cross the trunk. It was a VLAN allowed list, but I was like, oh, but VTP trunking, VTP pruning could have been a solution, because it could have said, but don't modify the trunk allowed list. And VTP pruning would have been the other way to go. But if you don't know the technologies, it's going to be hard to do that. And I did receive an email the other night asking if I was going to start doing anything layer 2 on the switches for full-scale labs. I said I absolutely will be. That's actually going to be coming very, very soon. I plan on getting through all of the CCIE labs, and that's actually how I'm going to start the full-scale lab. Is I'm going to do a full-scale everything layer 2. So there's a couple things that I had to go through on layer 2, like fallback bridging, VTP version 3, private VLANs, and I'm trying to think what the other one is. There's a couple of them. Let me swing this guy back up to the top here. What was it? VTP version 3 and private VLANs. I think that was multiple spanning tree. I have to go over that again, just so I know how to, for the most part, I know how to do that with multiple instances, multiple regions. The one that hung me up was doing port fast on a trunk port. And so I was going to go, okay, so I do have to, I wrote a mental note down on that to make sure that I tested that, so when it comes to topology change notifications. And then fallback bridging, macros, and then ER-span, span, R-span, and ER-span. Which span is you're doing you're mirroring information on the same switch to another port on the same switch. ER-span is when you're going across, or I'm sorry, R-span is when you're going from mirroring a port on switch 1, and you're sending mirroring that port to another switch on another port, and you go across a trunk link. So that's going to be rspan. And then ERspan is when you're taking it to a completely separate location and you're GRE tunneling that. So you're sending it over a GRE tunnel to another location and you're routing it effectively. So, and then we're going to be taking a look at PPPoE a lot. So a lot of my setups are going to be, okay, what do we do if we have a PPPoE circuit and we need to run this? So we need to obviously have that operational. And then there's a couple in here like VRF Lite. We're going to take a look at that in detail with actually setting that up to do a full routing table virtualization to where we can actually logically separate all of our traffic. Take a look at that, and also inter-VRF routing and see exactly how that would play out, because I have a feeling that's going to play a pretty heavy role when we get into MPLS, and that's usually the only place I've ever seen it. But you can run VRF Lite inside of your internal LAN to segregate, say, faculty traffic from student traffic, instead of having them on the same, instead of having them routed across the same physical interfaces. You can actually have them not even touch the same interfaces. So there's complete separation of the network. So that's just a couple of things we're going to be taking a look at as we go through here. We'll be taking a look at a BFD as well, and just getting that set up because it's going to be a little easier to do on CSR. But that's what I had going for you. I hope this has been informative for you, and I'd like to thank you for viewing.